frequency of the exact note you're hitting on the piano.
27.5, but you wonder how they just settled on that. It must have evolved naturally, and then at some point the technicians said, well, we want some exact value for this lowest note.
Yeah, it has something to do with our genome, I guess, on what frequencies we like to hear in harmony.
Mm-hmm.
So the lowest note that we go to before we start having problems determining the difference is pretty much in that area.
Uh-huh. Right. So there's the audible frequencies, and this is sort of getting towards the low end of the audible frequency, 27.5 oscillations per second. So the 44th note will be this, and so that's an exponential function, right? That's a nice example of an exponential function. So what does this have to do with the log scale? Well, you could take a log of that, and then I suppose you could say the base note is 27.5, and so you'd have the same sort of measure where if you have 27.5 times 2 to the n over 12, and you divide that by 27.5, and you take the log to base 2 of that, what have you got? Maybe you need to multiply that by 12. Then you would actually have, first of all, you'd cancel the 27.5, right? But this 27.5 is sort of playing the role of the standard earthquake here, right? It's your baseline, right? It's the lowest measurable thing. And on the piano, that is, I guess, 27.5 hertz. Hertz being cycles per second or oscillations per second. And this is then the oscillation, the rate of oscillation of the nth note on the keyboard. So if n is 0, this will give you, I guess, log of 1, which is 0, right? 2 to the 0 power is 1. And then you get n over 12 for this, right? Yeah, I'm not sure if that's a standard measure of anything, but it could be, right? If you wanted to build one, that would be a good start.
That one, that should match like all the other instruments because you play in the same key.
Yeah, the piano is sort of the ruler of the roost.
Yeah, what will change will be the n over 12 part. That's specific to the piano. That part will change to like n over probably 24 or something. My thoughts would be. The range.
Well, the scale has 12 notes, no matter what instrument you're playing on.
Yes, I guess the 27.5 would be different.
Detuned. But yeah, so the whole point is, so here's the problem, is that if you triple the frequency, what do you get? Well, you also get a very nice harmony, right? But it's not 2 octaves, right? To get 2 octaves, you have to fourple. Is that a word? You have to multiply by the frequency by 4, right? Because every time you go an octave, you multiply by 2. If you do that twice, you multiply by 4. So what if you multiply by 3? What do you get? Well, it's the other most consonant harmony. It's the next most consonant harmony. It's the 5th note in the scale. So you'd want 2 to the 17th over 12 is the 5th. Oh, sorry, that's not the 5th, right? So you've got.
No, that's correct. That's the 5th. You're
it's
up.
the 5th semitone, but I'm thinking of the 5th note in the scale, right? So G above. So you go like C, C sharp, D, D sharp, E. Then there is no sharp. F, F sharp, G, right? And so this is what's considered to be the 5th, and that's supposed to be nicely harmonic. So it should be, 3 times the frequency of the note of the C down here, right? So you have B here, and so this should be 3 times the frequency of this note, right? And so where do we go? 1, 2, 3. So this is 12 notes above, right? And so that would be twice the frequency of this C. And then you go 13, 14, 15, 16, 17, 18, 19 actually, right? So 2 to the 19th over 12, is that approximately equal to 3?
It's pretty darn close.
It's pretty close.
Yeah, because then you would need to get to C from there, so you have, that'd be double, triple, quadruple. Yeah, no, actually that is probably there now that I think
Yeah.
about it.
So I guess I have to go to Google or something to do calculator on here. But I get 2 to the power, what did I say, 19?
Yeah, 19 over 12.
19 over 12. And I'm getting, 2 to the power. I'm getting only 2.16.
Oh, you gotta multiply it by your 27.5 to get the hertz, because you wanted to see if it was double compared to before.
I'm not happy with this. Oh, sorry, 19 over 12. I got 19 over 17, which is good grief. Yeah, I don't have to, I mean, that's just the multiplier, right? So it turns out this is 2.9966.
Mm.
Well, it's 2.9966. Is that close enough to 3 for the human ear?
Yes.
Depends on who you ask. If you ask Johann Sebastian Bach, well, you can't because he died. But if you had gone back to, where was it he lived? I think Switzerland, actually. Basel. I think Basel was the town where this came up as an issue back in the 17th century sometime, I believe, or
He's in Germany. Bach, right?
yeah. Yeah, he is German, but I think he worked in Basel. He lived and developed a bunch of his work there, as many Germans did. It became a big issue, let's say. And so, how do you fix this problem that that's called the well-tempered clavichord, because they didn't have pianos in those days. So
Actually, you raised an interesting point. So from, I don't want to get too off topic or anything, but
Yeah.
are you saying with music there's a relationship between the hertz and and what you call the musical fifth, the dominant? Like it always is like sets of like 1 times 2 times 3 times the amount of hertz. Is that what we consider harmony?
yeah, so a perfect